What's up, guys? Welcome back to the dev channel, Max Codes. I have not posted a video in about a week, and in this video, what we're going to be doing is we're going to be learning how to build out a linked list in Swift, okay? Now, this is actually pretty simple, but if you've never really done anything with computer science, you've never taken any algorithms or data structure classes in a CS program, for example, like I have, then it might be a little bit hard for you to understand, okay? But it is a great opportunity to learn, and I highly suggest you learn how to build out a few of these algorithms and data structures that I'm going to be putting on the channel, as it will help you learn how to think better and program better in the Swift language, okay? It'll also help you understand how generics work and kind of how things work under the hood in Swift a little bit more than you might have known before, okay? Now, we're obviously not going to learn a lot under the hood of Swift, but what I'm saying is there's a lot of functions and stuff that you probably use, and methods and data structures and algorithms that you really don't think of as too complex until maybe you look up algorithms and data structures, right? So I'm here to show you kind of how to do this in Swift, and yeah, let's go ahead and get started, okay? So what you need to do is create a new Xcode playground, all right? I'm just gonna go ahead and open up Xcode here and hit File, New, Playground, okay? So I'm creating a new playground. Let me drag that on the screen here, and I'm just gonna create a blank playground, all right? Now, so I can better explain how this all works, what I want to do is kind of follow along with my Medium article I wrote, okay? Because I wrote it out and I have some notes here that I kind of want to go over just to help you understand the theory behind linked lists, because it's really hard to understand and code out if you don't really know what's going on, right? And I really want you to understand. Okay, so what we need to do is first create our little playground here. I'm just going to call this linked list. And I'm going to create that, and I'm going to get rid of this string. But if you don't know how playgrounds work, what you're going to want to do is hit play, and you'll see we have this string, and it should say it over here. You can also print out the string, and it'll say it again. I'm sure you all know how playgrounds work. Okay, so I'll zoom into the code a bit. And the first thing we really want to do is kind of look over the theory of our linked list, okay? So you'll see here the objective is to create a linked list in Swift 5 and Xcode Playgrounds. I have my two websites. Don't worry about maxnelson.io. That's just like for my app projects and stuff. But that, maxcodes.io, is where I post my courses and stuff like that. Feel free to check it out if you want. Okay, so what we're going to do is go down here, and let's see, it had my old changes there. That's really weird. Let me reload the page here, and we will talk about what a linked list is. Okay, so a linked list is a collection of nodes, each node containing data and pointers to the previous and next node in the collection. This differs from, say, an array in that a linked list is data is not ordered by a node's physical placement in memory, but instead which other nodes it is connected to, okay? So kind of think of people in a line holding each other's shoulders. They're all kind of connected to each other. But yeah, let's go ahead and look at these diagrams here, and you can kind of see better what I'm talking about, okay? You'll see we have each one of these nodes, and they're connected back and forth, okay? So if you read here in the Medium article, how do nodes connect, you'll see that I have an image here. If it would load up, it looks like my Wi-Fi is being a bit slow, but essentially it just looks a little bit like this, but a little bit different. There's only one line, and once that loads, I can kind of show you what's going on. Okay, so you'll see we have all these nodes and they're connected together, right? You'll see this is basically just a singly linked list, okay? Because we have the node and it's connected to the next node, but it's not really connected back to the node. So the only way we can really get data is by going to the head here and traversing over here to the tail, okay? Now let's go ahead and read this. It says we'll be creating a doubly linked list whose nodes contain not only a next node pointer, but also a previous node pointer. Okay, so this is a doubly linked list. Essentially, what we can do is we can have a reference. We have a reference on each node to the next and previous node. Now for this node and this node, these values are nil because there's no other node. Now, if you wanted to create a circular linked list, you could reference the last node as this node, and then it could be kind of like a circle. Okay, again, this probably doesn't make a whole bunch of sense if you've never done this before, but continue on and we will learn as we go on, okay? So the head and the tail, this is important to understand, okay? We have the head here, and then we have the tail here, okay? Now, like I said, the head's previous node is nil because no node comes before it, and then the tail's next node pointer is nil because no node comes after it. Okay, now the performance, we can talk about that after we've kind of written these things because it doesn't really make sense to talk about it right now if you've never really done any algorithms or data structures because it just won't make any sense. And it's all in relation to the methods that are within this linked list, okay? So here's the plan. Let's create our node class and let's create a linked list class, and we'll do a few of these. We won't do all of these, okay? So what I'm gonna do is create the node structure, okay? Let's go ahead and flop over into playgrounds here, and let me expand this a bit. And what we're gonna do is we're just gonna create a node class, okay? So we're gonna create one of those nodes that belongs in our list, and then we'll use it inside of our linked list. So we'll say public class LL node T, and the T is generics, okay? Now, if we wanted to explicitly say this was gonna be a value of string, we wouldn't have to put this, but we might wanna put data inside of our linked list that isn't just strings, right? We might wanna use integers, for example, okay? And that's what generics solves. So it says generic code allows you to write flexible, reusable functions and types that can work with any type, okay? Subject to the requirements that you define. So essentially what this means is that we can use this linked list not only with strings, but also with integers and other stuff like that. That's pretty much all you need to understand about generics right now. But if you want to dive deeper into it, feel free to check out this website right here in the Swift documentation. Okay, so let's go ahead and go back to our code. Let's create this and we'll say var value is of type T, okay? Because it's going to be of any type. Then what we'll do is we'll say next is LL node, and then we'll say var previous is of type LL node. What this allows us to do is it allows us to keep track of the next nodes and the previous nodes in the list. Okay, and then we just need an initializer. We'll say public init value. We're going to take in the T, and then we'll say self.value is equal to value. So essentially, you can think of a linked list node as our value in the array, okay? You can just think of this as like a string or like an integer, right? The reason we have a class though is because we, again, are linking to other nodes that have values. But really, the only thing that this node really does for us, well, other than link to other nodes, is it has our value, right? So our linked list node has a value, and then it also has next and previous nodes to link our list together. Let me go ahead and scroll back to the article and just show you that image one more time. Okay, so you can think of these arrows as the next and the previous, okay? So the previous and the next, the previous and the next, and that connects all of our nodes together. Notice how these are also linked list node types. Now it has to be optional because we need the ability for the tail and the head to have nil previous and next nodes, and that's why that works. Okay, so what we're gonna do is declare our linked list now. We'll say public class linked list is of type T, and then we will define a public type alias node equal to LL node T. Now, why am I doing this? Well, there's a couple things I want to talk about here, okay? First off, we're calling it LL node because if we type this alias and say we just called it node, it wouldn't really work because it thinks that we're like redeclaring it, right? It thinks that we're setting node equal to itself kind of thing, okay? So that doesn't really work. If you compile that, you'll see it doesn't work. So I'm just gonna call it LL node. Feel free to call it whatever you want. Looks like there's a bug here in the playgrounds of the beta. Notice how I can't scroll up, but that doesn't matter. We don't really need to go up there anymore anyway. But essentially, that's why we're doing that. But why are we using a type alias? Well, it's because whenever we declare a node, say head, we'll say private var head, we don't want to say, for one thing, LL node, but we wouldn't have to do that if we didn't use the type alias, right? We could just say node. But here's the catch. Watch me say LL node. And I'll set this equal to optional, right? Let me compile it. You'll see that it says reference to generic type LL node requires arguments. Okay, so if we wanted to type this out every single time we declare a node, we definitely could. But it's a lot easier to use a type alias and avoid that little any, okay? So all we have to do is say node, okay? Okay, so that's why we're using the type alias. Okay, so we have our head, But the next thing we need is the first. Okay, so we'll say public var first node, and we'll return the head because the head is our first in the list. Okay. The next thing I want to add is an isEmpty Boolean value. So we'll say public var isEmpty bool is equal to type return head is equal to nil. Okay, now let me explain what's going on here. Say we have our linked list. Okay, so let's declare it. Let's say let list is equal to linked list. We'll make it of type string with our generic here. And then what we'll do is we will say list.isEmpty. What's this doing? Well, we're just checking if it's empty. Okay, so it's going to say true, it's empty, there's nothing in there. How is this working though? Well, we're saying is head equal to nil, which it is. So yeah, it's empty. And the only way we're going to have a head that's not nil is if there's at least one value in the list because it's the head, right? Okay, so since we don't have a head, then it is indeed empty. Okay, so what do we want to do now? Well, we kind of want to insert data into our list or append data. So let's go ahead and write a function where we can append data. We'll say public var append, sorry, not var, but public func append, and we'll take in a value of type t because we don't really know what value we're dealing with, right? Could be an integer, could be a string, but well, basically it knows at the time of compilation that that's going to be a string or an integer is what I'm saying. Okay, it's going to take in whatever we passed in here. So at the time of compilation, it knows this t is a string, okay? Okay, so what we're going to do is say let new node is equal to node, and we'll say value t. So we just created a new node. That's irritating that I can't scroll up all the way. But essentially, we created a new node with a value of whatever value we just passed in, okay? So make sure that value passes in value, not t. Okay, now how do we kind of link the head to this new node? How do we kind of get this effect right here? Well, it's pretty simple. All we have to do is set a previous and a next node on the new node and the head. Okay, so all we have to do is say if let last node equals last. Let's see, we didn't declare a last, did we? Let's go ahead and declare that real quick. Right below head, I want to say public var last node is, and then we'll type in some logic here. Okay, so completely kind of forget about append. Let me paste that there. We'll move on to that after we talk about last. Completely forgot about adding last. So in last, the way we can get our last node or the tail is by saying guard var node is equal to head else return nil. Okay, so basically we're saying make sure that there's at least a head else there is no last. Because if there's no head, then there can't be a last, right? That doesn't make any sense because there's no list to begin with, so there can't possibly be a last. But if we do have a head, then there could potentially be more nodes in our list. How do we get to the end of the list if we have 10 nodes? Well, we just need to kind of we need to traverse down it by saying, okay, what's the next of our head? Okay, what's the next value of our head node? And then what's the next value of that node? This is really, really confusing to understand if this is your first time. If you're reviewing linked lists, like it was for me when I came around and learned this a couple days ago, then you might be like, wait, what's going on? Okay, I understand it. All right, that might be happening. I might be going through your head right now. But essentially what we want to do is just say, we just want to say while let next is equal to node.next, then node is equal to next. And again, this probably doesn't make any sense to a lot of you because what's going on here? Well, we're basically just saying if head has a next node, okay, if it has a next, I'm using my hand. I'm like putting my hand against a screen, but I can't really show you my hand. Maybe I should start filming my face on this. Essentially, we are saying if the head has a next node, then set the node equal to that next node. Okay, and then what's going to happen is it's going to go back to this while loop again and say, okay, well, what if next? Let's see if next node.next has a value. And we're just going to traverse down it. Okay, we're going to go boop, 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 and we're going to get to the end of our list. So let me kind of illustrate this here in Sketch. Let's just copy this real quick. Let me copy this and let me look at this. Okay, so say we have a head. All right, we have a head and that didn't return nil. Okay, now let's go ahead and set next equal. What I'll do is I'll put some text here and I'll just say next. Think of this as like a box. I just don't want to type out or write a huge box in here, right? So think of it as a node. This is a node right here, just like one of these squares. while next is equal to the head, right? Dot next. Okay, so while that is equal to this, then we'll continue it, right? Let me increase the thickness of that. Okay, so now our node is equal to the next, okay? Then what we're gonna do is kind of get this node, right? And that's now next, okay? And we'll say, okay, well, does that have a next? Then yeah, we're gonna use that node and so on. And eventually we reach the tail, okay? And when tail doesn't have a next, you'll see it's nil, then this is gonna break and that's not gonna run anymore. And we can just return the node because we know we reached the last node. Okay, hopefully that makes sense. Okay, so back to append, and then I'll end the video because I don't want to explain all of the things in here. The rest are on my Medium article, and I'm probably gonna make a few videos on this. Maybe even delete this one and write a new one, or record a new one, just because this is kind of jumbled and it's my first time doing a data structure. Okay, so we'll say if let last node is equal to last, then what we'll do, let's kind of think, I have to think about this for a second, hold up. So we're appending, we've created our new node, and we're saying if let last node is equal to last, okay, so we get our last node, then we will append it to the end of our list, right? We want to throw this new node to our tail, right? That's the whole point. We're appending it on, and we want this new node to go to the tail and be the new tail, right? We eventually want this tail to be right here, okay? So what we're gonna do is we're gonna get our last node, go through all the logic we just did in this var last, and then what we're gonna do is reset the previous and nexts on a few nodes. So what do we wanna do here? Okay, we wanna take our new node and set its previous to the last node, okay? The tail. So its previous to the last node. And then what we wanna do is take the last node's next and set it to the new node, okay? And that's basically going to reset our tail, and that's now our last node. So let's go ahead and type out that code. We'll say new node dot previous is equal to last node, and last node dot previous, sorry, dot next is equal to new node. Hopefully that makes sense. If it doesn't, just really kind of conceptualize this. And what really works out for me is drawing these things out. So I highly suggest you open up something like Sketch, or you open up anything that lets you kind of draw, even if it's on pencil and paper. Maybe you have an iPad with an Apple Pencil. Just visualize it by drawing these things out, and you will understand these things so much easier and faster. It's hard to kind of all comprehend it in your head at one time, right? I like to compare it to RAM on a computer. Okay, so else what we're gonna do is we're gonna say head is equal to new node. Let's talk about this though, okay? What's going on here? Well, if we don't have a last, then we don't really have a head, right? Well, we might not have a head, so let's just set head equal to new node, okay? Let's think about that a little bit further. Let me explain it a little bit better. I really want you to understand. If we're calling last and there's no head, we're returning nil, right? So if this fails, the only way this is gonna fail is if it's nil, right? If last is nil, which means we don't have a head or a tail, which means we just wanna set the head to new node. This is if our list is empty. So if I go down here and say list.append, and I say Max Nelson or maxcodes.io, it's going to basically just give us, here, let's see, value. Let's fix that. It's basically just going to put this as our head because we don't have any nodes in our list. So let's go ahead and print the value right here. Value is, and you'll see that it runs that line when we play this. Okay, you'll see it says value is maxcodes.io. Okay, but if we add another one on here, and I say, I would say maxnelson.io because that's my other website, but I don't want it to be confusing in the terminal here because that looks so similar. What I'll do is I'll just put bro, okay, and you'll see that it now runs this up here. Let me copy this and put it here. You'll see when it prints this one, it's gonna print bro. And then this one's gonna print maxcodes.io. Let's go ahead and hit play there and see what the junk's going on. Okay, so hopefully that makes sense. Hopefully this is a good introduction to some of the methods in LinkedList, and I hope that this provided any value to you. If it didn't, let me know in the comments, And again, I'm going to be uploading multiple parts to this, and I'll probably even re-upload this series, okay? So if this video is not cutting it, just make sure to check out on the channel, search LinkedList, because I'm very likely to leave this video on the channel, but remake this video to be a little bit more understandable, okay? So that's it, and hope you guys enjoyed the video. Let me know if you want to see it, and check out my other channel, Maxwell Nelson or Max Nelson or whatever it's called. I'm going to be posting developer vlogs because I want to do more than just coding on YouTube. All right, that's it. See you guys in the next video.